are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to Techgig webinar series. Today we have Vignesh Murli Natrajan. He is a senior associate at Cognizant. Vignesh is an architect, innovator, trainer with expertise and experience in web development. He is an artist with passion in graphics and animation. Topic for today is creational design patterns. A quick information for the attendees. Vignesh will be giving the presentation for the first 40 or 45 odd minutes, and we will start taking in the questions during the last 15 or 20 minutes. You can start sending the questions by around 3:30, and I'll start assigning them to Vignesh. So without any further delay, I hand over the session to Vignesh. Over to you, Vignesh.
Good evening, ladies and gentlemen. A very warm welcome to this Techgig session on creational design pattern. This is Vignesh Murli Nadarajan. I'll be your presenter for the rest of the hour, and I'm happy to see all of you. Today we'll be talking about the various creational design patterns, but we do not just jump into the creational design patterns. We'll talk gradually, understand what is design patterns, and then what are core design patterns, and then gradually work our way into creational design patterns. We'll see about all the creational design patterns. I have a lot of examples, and if you have any questions, feel free to shoot them out to Sri Lagna, and I'll be able to answer them. If not in this session, I'll also be able to address your questions offline after this session. Having said that, let me get into the session right away. So the topic of the day today is creational design pattern. And we are going to be addressing primarily these objectives. What are design patterns? What are the gang of four design patterns or core design patterns? What are creational design patterns? Of course, the primary motive of the day is going to be talking about creational design patterns. We'll talk about all the 5 available creational design patterns. What are the differences? How precisely to use those design patterns? And when to use such design patterns, right? So those are the objectives that we will be covering the next hour. So to begin with, we'll start with design patterns. Sure, most of you out there are architects or designers for your respective concerns, and you'll have a lot of experience, at least some hands-on experience on design patterns. If not, don't worry. Design patterns is only a concept. It's a concept, not a technology. We have a concept derived from experience. Design patterns are, if you dissect the term design patterns, you have design and patterns. Pattern signifies the fact that this thing is going to be recurring. It's going to be seamlessly recurring over and over, and design patterns simply means you have solutions that can be applied over and over for the same problem that recurs for us. Right? So in a nutshell, it's standard proven solutions for recurring problems. That's all there is to a design pattern. Not a technology, it is not a specification. We don't have any compiler or a server that's going to enforce that our design pattern implementation is correct or wrong, right? So that is of paramount importance here, because we are all by ourselves. Our implementation of these design patterns is plainly based on our understanding. We don't have an external mechanism like a compiler or a Java virtual machine or something that could validate if we indeed use the correct design pattern, and if so, if we use the design pattern correctly, right? So those are design patterns for us. The key thing is we have a context, we have a problem, and we have a proven solution for that problem. And this problem occurs over and over in multiple contexts and appears to go away with the application of that solution. And those solutions are called design patterns, right? So it all originates. So this is, in a nutshell, what design patterns are. These are expertise derived from experience. Today you and I are working on a problem, and tomorrow our colleagues are facing the same problem. The day after, our competitors are facing the same problem. So all these problems get accumulated, and they become experience, knowledge gained out of experience. And instead of reinventing the wheel over and over, we tend to say, hey, we tend to document those. Hey, I bumped at this problem and I banged my head for 3 days, and this is how I addressed it. And that becomes a design pattern. And remember, it's not, I was just talking in terms of layperson. It's not just you and me who can document design patterns. It has to be relevant. It has to be very ubiquitous to be termed as design patterns. For instance, I don't know how many of you here are Java persons. I'm a hardcore Java person, and I got my feet wet with almost all Java technologies. So in Java, there is a popular pattern recently with the advent of Spring framework called dependency injection. It is also popular with other technologies, but the dependency injection or inversion of control has been around for quite some time. And for it to gain the prominence to the point where it can be considered a design pattern is just now. Because out there, the inversion of control has been out there for decades at large, but right off late, it's been called design pattern. So there is no authority. It's only experience and the ubiquity of the problem decides whether that problem and its solution can be considered a design pattern or not. All right, so I understand what a design pattern is, right? A design pattern is you have a problem, and that problem is very ubiquitous. Many of your colleagues or many of your predecessors have faced those problems, and how do we fix those problems? You reuse the same solution that the predecessor used, and if not, improvise on that solution. That's your design pattern. All right, I understand what design patterns are. Why do we go for design patterns? Well, it's pretty simple. The answer is right there in what design patterns are. It prevents reinventing the wheel. You don't have to create the design pattern over and over. You don't have to create a solution, right? Someone has invented a solution. Why would you spend the entire time traveling the same path instead of leveraging on top of what was already found? That's the idea. So the design you employ design patterns, mitigate and reduce the amount of risk, and just reuse back on the solution that somebody has found and has spent time in investigating whether it indeed solves the problem. So it's a ready-made solution. Why would you want to invent your own unless you have a very valid purpose to do so? So you don't have to solve any problem or every problem that has a design pattern attached with it right from the scratch. Right? If you are talking about a DAO, hey, I know they're writing database objects. Fine, let me create a data access object pattern. I am talking about a service locator. Let me simply create a service locator pattern. I don't have to worry about the problems that may have been caused when these patterns were not used. I know if in this context, if I have such a problem, this is how I attack it. If I need to find services at runtime, I'll simply use service locator pattern. Right? So that's the idea on why you should use design patterns. And again, these are all proven solutions. You don't have to doubt them as long as you are able to apply them properly. Remember, design patterns do not have any kind of virtual machines or compilers to verify and say, hey, you've done it correctly. In fact, you could simply create some ABC pattern and call it factory pattern. You could just create a class and call it factory method. It is going to assert that it's indeed factory method pattern. And that is why I feel that it's of paramount importance that you have to understand what design patterns are, why should you use design patterns, and to use which design patterns. Right? So, with why design patterns out of the way, our next topic would be to discuss about the core design patterns, or as it is popularly called, the Gang of Four design patterns or GOF design patterns. The Gang of Four simply refers to 4 authors of this book called Design Patterns, Elements of Reusable Object-Oriented Software. That book is a very popular book. I think it was published in the 1990s, and more than 500,000 copies of that book has been sold out in different languages, not just one language, right? It's a very important book, and the beauty of that book is, until then, there was no documented style of design patterns. Everybody had, it was anarchy, right? Everybody said they have their own set of design patterns. But this quickly became a Bible of the design patterns concept, right? And in that book, authors have had beautifully, divided the entire book into the first book discussing about object-oriented design principles, and the second section talking about the various categories of design patterns, and the third section I think was talking about case studies. So they took an imaginary case study and then they went ahead attacking the problem, how to solve them using these design patterns, right? So these are the way, this book is of paramount importance. If you have the money and effort to afford it, please go and fetch a copy. Excuse me, people. Sorry about that. So the elements of reusable object-oriented software design pattern book is not just applicable for a particular language. As its name suggests, it's applicable for all object-oriented paradigms. Your programming language is using object-oriented paradigm, you can use that, right? So that's the idea. And like I said, in that book, the authors had categorized design patterns into three broad categories: creational design patterns, structural design patterns, and behavioral design patterns. The creational design patterns, obviously, all of us know, is going to be attacking the concern where you're given the problem of creating objects. Some of you might immediately wonder, hey, is object creation such a big concern? Why should I even worry about going for creational design patterns? Or why is it given an unfair justice or unfair attention? Structural, all right, it talks about my application and its built-up structure. Behavioral is going to be runtime behavior. Why should I give special onus for creational design patterns? And that's what we'll talk about today, right? So creational design patterns, there were 5 creational design patterns under that category. Under structural design patterns, I think there were some 9 or 8 design patterns. Under behavioral design patterns, we have around 11 or 12 design patterns, right? Of course, the structural design patterns and behavioral design patterns are not in scope for this day, but I promise I can do it in a future session if required, all right? And the primary focus that the authors shed in that book is how to use object-oriented principles when it comes to design. Some of the best practices were documented as part of the book. The reason I'm talking about this book is it is the Bible. It should be regarded as the Bible for design patterns. They give clearly what each design pattern is, when should they be used, when not they should be used. All those nitty-gritty details have been provided beautifully in that book, right? And it is from that book arise these topics called creational design patterns, structural design patterns, and behavioral design patterns. All right. So in a nutshell, the authors in that book try to convey, hey, if you're using OOPS principles, if you're designing something using OOPS, try to minimize inheritance. Favor composition over inheritance. That's a core design principle that the authors have conveyed. If you're trying to do something using subclasses, avoid it. Avoid it to the maximum extent possible. Instead, use interfaces. So you program to interfaces and not to implementations. So those are some best practices that are available in the book. If you have the time and money, just go and get a copy of that book. You have PDF versions as well. So get that book. It's a real asset for any aspirant architect or any architects out there. All right. So we've seen what are design patterns, why should you use design patterns, and what are core design patterns. So the core design patterns fall under 3 categories: creational, which addresses the concern of creating design patterns. The structural design patterns talk about various patterns that you could employ while you're building your application. This is about the structure of the application, not the behavior of the application. In other words, these are the modules. How are your modules supposed to be built? How should they be connected with one another? That's what is conveyed using structural design patterns. Again, no 2 patterns are the same, right? Every design pattern has a particular solution that justifies its survival. Okay, and finally, behavioral design patterns are talking about how to attack some of the runtime problems. Some of the behavioral design patterns include the visitor pattern, we have the state pattern, we have the observer pattern. Those are behavioral design patterns. And structural design patterns, we have adapter, bridge, all those come under structural design patterns. The composite design pattern is also structural design pattern. Okay, so those are the various categories of design patterns. And on to the primary topic of the day, which is our creational design patterns. Like I said in the beginning, the creational design patterns attack just one concern: object creation. Okay, and there are 5 creational design patterns identified by the Gang of 4. Those are the factory method design pattern, the abstract factory design pattern, the Singleton design pattern, the builder design pattern, and the prototype design pattern. Each of these design patterns has its own style of creating objects or constraints on object creation, and you could mix and match. There is no dictation that you must use only one of these design patterns. Of course, there is no hard and fast rules when it comes to design patterns. It all goes out of experience, and you use what best fits your needs, as long as it makes sense for your application, right? So we have the 5 creational design patterns that we are going to talk about in a few minutes. But before we start talking about these creational design patterns, let's understand why should this creational design patterns be, or why is there a separate category just for the sake of object creation? For most object-oriented programming languages, we have the new keyword that's able to instantiate an object in a jiffy. Why should I even bother about creating a design pattern? Creating a design pattern category just for creation of objects? The answer is pretty simple. You don't have to use creational design patterns every time when you need an object. It's only in areas where you see diversity. When you see that certain areas of code that create objects is going to be very volatile, that it's prone to change. It needs to be flexible, right? There are so many situations. If you're a seasoned developer, if you've been doing applications for quite some time, you should definitely understand that whenever it comes to object creation and all that stuff, the business logic will always remain the same. You have a core setup, and you subject various objects through that core setup or business logic. So what actually varies is the object that is subjected through that algorithm. And indirectly, that also refers your object creation can be very diverse, while the business logic itself could be simple. I just said could be. I did not say will always be, right? Of course, business logic could also be diverse. But what we're trying to address is a situation where you're also trying to create an object at the same time, try to get some benefits out of it. For instance, writing a business logic, writing the same monotonous business logic for each and every different object that you may create. The algorithm is the same, but you keep repeating the business logic over and over. The only thing that changes is the object creation. And that's what is addressed by the factory method pattern. So the idea is we are trying to create objects, and not just objects, at the same time try to make the best use of what is available. Like reuse the business logic, mitigate the amount of impact that could be incurred if some portions of the application has to change. Right? So these are various concerns that are attacked by the creational design patterns. So let's quickly run through the various creational design patterns before we jump for a deeper dive. Okay? The factory method design pattern is what is best suited if you're talking about having multiple instances, multiple variants of an object subject through the same algorithm. If it does not make a lot of sense in the first go, don't worry. We are just seeing the overview. We'll take a deeper dive in shortly. Okay. So the next design pattern that we have under our belt, we should see under our belt is abstract factory design pattern. The abstract factory design pattern is what you would use when you need to create families of objects as opposed to just variants of one object. Remember, that's what we said factory method pattern does. It's variants of a single object, or descendants, to better put it, descendants of a single object. But abstract factory creates descendant of a family of objects. Singleton is the simplest creational design pattern. I'm sure 99.9% of you out there should know what Singleton pattern is. It restricts the number of objects a particular class can have to exactly one, not more than that. And then finally, we have the builder and prototype patterns. Prototype pattern says, hey, whenever you create design pattern, whenever you need to create an object, if you are having a particular situation where you could save time by cloning an object, then that's when you go for prototype pattern. So you just create a base object and you keep replicating it whenever you need instances. That's when you go for the prototype pattern. And then we have the builder pattern. The builder pattern is the most complex of all, or could address the most complex situation of all. Right? The builder design pattern is unique in the nature that all other design patterns give up the objects in one shot. But the builder pattern can be directed. it could go step by step. It has to in fact go step by step, right? So you build the object gradually and eventually you get the final object. That was not the case with the factory method, abstract factory, singleton, or prototype design patterns. You build the object in one shot and you get the object, final object. But in the builder pattern, as its name suggests, you build the object gradually and sequentially over multiple steps, which also gives you the ability to dynamically change the behavior on how the object is built. All right? So, with that out of the way, let's start our deeper dive. So, before we get into our deeper dive where we are going to talk about factory method design pattern, let me just quickly sum up what we saw so far. We saw what design patterns are, why should we use design patterns, and what are gang of four or core design patterns, what are creational design patterns, what are the various creational design patterns in a high-level overview, and the next topic is the deeper dive. So the first design pattern and a simpler design pattern that we'll talk about is factory method design pattern. People remember that most people just call it factory, which leaves us an ambiguity where we don't know if that person is referring to the abstract factory design pattern or the factory method design pattern. So it is my advice to you to use the precise name. So the two patterns are completely different. The abstract factory design pattern is completely different from the factory method design pattern. They are not the same. Okay? So the first design pattern that we'll talk about is the factory method design pattern. The factory method design pattern, all it does is creates variants of a single class. You have a single class, and when I say variant, I mean descendants, right? You have a car, you have a bus, you have a motorbike. What are all these? These are descendants of a vehicle. So a factory method design pattern can be used to create descendants of vehicle. That's to put it in the context of an example, right? So it lets you to create various objects that descend from a single parent, but at the same time, all these objects, despite their differences, will all be sharing a common business logic. This is a very important concept that most people underlook. You know, the common misconception among some architects and designers, at least the ones that I saw, is they tend to call any method that's creating an object as factory, which is not really true. Any method that creates an object cannot be called factory pattern. And so the terminology is pretty important. We have the factory method design pattern, and then we have the abstract factory design pattern. These two are precisely named so, and we should use the correct term, right? Because they have very drastic differences between them. The factory method design pattern is just one method. The abstract factory is a sequence of classes, right? The factory method design pattern is helping you to create variants or descendants of a single class. So recollect our vehicle example. You have a vehicle and you have multiple descendants from vehicle, which could be car, bus, truck, and motorbike. All these are various descendants of a single parent. So that is our factory method. That is the situation where you use the factory method design pattern. And not just that, you have the unique requirement where all these objects must share the same business logic. Okay? So how do we achieve this? We'll see an example. Don't worry about it. Let's first discuss the features of the design pattern. And then we'll see examples, and then we'll get into some other design patterns. So the next topic we have is, the next thing we have to discuss is all objects that are created conform to a common interface and it favors inheritance. So these are the lines that I'm reading from the PPT. So for now, understand the factory method design pattern gives you one method that is able to create instances, various descendants of a single parent class, and then it gives you the ability to share the same business logic. It relies upon inheritance to achieve the task. All right, so that is very important. It relies upon inheritance. We'll see how it works in a while, but let's first see the UML diagram that factory method design pattern is representative of. So you have a creator, which is a superclass, and we have a concrete creator, which is going to be an implementation or an extension of the creator class, and the concrete creator is going to create the product. Where is the factory here? factory method is sitting in the content creator class. You may ask me, all right, what's the purpose of the creator class then? The creator class is where you'll put the entire business logic. So the creator class will have the entire business logic and will have an abstract method when it comes time for object creation. So the product is an object and it uses a factory method to create that object. Remember, product will be a superclass. It will be a parent. So we are coding to interfaces, not for implementations. Right? So what did I say factory method is capable of? It's able to create descendants of a class, and that method is this. The factory method, which is declared as abstract in the parent, is our factory method, and it has its implementation in its children, and the children are creator classes. The rest of the methods in the creator will be on your business logic. So if you take a step back and see what this diagram is trying to convey you have all your business logics in creator. That's going to be the same. It's not going to vary. It will be the exact same class, one class. All business logic is inside that class. And when it comes time for object creation, you have an abstract method, which means the superclass itself is incapable of creating the class. So who's going to create the class for you? It's going to be done by the subclasses. We have various subclasses that will implement the creator. When I say implement, I mean it's an abstract class, so it will become a subclass of creator, and each of these concrete creators will have, or idealistically should provide just the implementation for the create method or the factory method. So you have as many concrete creators as you have products. So in our car example, the creator is a superclass, and it will say, hey, the factory method is supposed to provide only the car. Okay, the factory method is supposed to provide only car instances. It does not care what it's supposed to provide, all right? But the concrete creator will say, all right, this concrete creator is called car creator. We'll have another class called bus creator. We'll have another class called truck creator. All these are extensions of the creator class. And by virtue of extending the creator class, all these inherit the common business logic, which is still maintained only in the creator superclass. But all of these concrete creators, like the bus creator or the truck creator or the vehicle creator, all these creators will have their own implementations for factory methods. Okay, so let's see a quick example. I'm a Java person, so I can give you only an example from Java. If you're not a Java person, bear with me, but you could still make out what I'm trying to explain from the classes. All right, so my example here is going to depend upon, again, a car example. Okay, let's look at this. We have a car factory, and a car factory has various lifecycle methods. Like I have an assemble car, build car body, set car body in lane, attach engine, test engine. All these are various lifecycle methods of manufacturing a car. That's all part of the car factory. Any car factory should be able to do all these. And remember, when you talk about a real car factory, all these methodologies are done by robots, right? They do not create robots for each and every different car that the company is going to manufacture. They tend to share the assembly line. A single robot is able to attach or do its job for multiple cars, right? So this is a classic situation for our factory method example. So our life cycle or our business logic will remain in our abstract car factory, which is our superclass. Okay, so I'll have my logic for setting the car body in lane. This is a robot, right? So this is present in the parent class. Attaching engine is another business logic that's going to be present in the parent class as well. So my entire business logic is sitting in my abstract superclass or abstract car factory. What is not present in this abstract class is how to build the car body, because the car body is built differently based on the car, right? So as you could see, the business logic is common. It's at the superclass level, but the object creation piece has been left abstract, and the children are supposed to provide implementations for that factory method. So here I have Chennai SUV factory that's able to provide an implementation of the build car body method. As you can see, the build car body method extends from abstract car factory. So what was left abstract in the parent class has been implemented here in the subclass right here. And only this creation is done here. Everything else is from the parent class. So by virtue of doing that, I have all my classes all my subclasses share the same business logic while they have different object creation mechanisms. So if you take my Delhi car factory, that has a different mechanism. And when you take the Mumbai sedan factory, that has a different mechanism. So all these are various implementations of the same abstract car factory, but they provide or they share the same business logic. All right. So this is with reference to the factory method design pattern. So again, the questions are open. So if you have any questions, feel free to drop those questions in the chat. I'll be able to answer once Srilekna filters those questions. All right. So let's come back here and deal with the next pattern that we're supposed to cover. We've just dealt with the factory method pattern. The next pattern that we have to discuss is the abstract factory design pattern. The abstract factory design pattern is the next level of the factory method design pattern. As you can see over here, it creates variants of a family of classes. Over there in the factory method, we said, hey, it's going to create variants of a single class. So you have a vehicle and you have various implementations of a vehicle. And that's what's done by the factory method. But when it comes to abstract factory, you have a family of classes. And what do I mean by family of classes? All right, take different companies. You have Honda, you have Toyota. Honda makes cars, Honda makes SUVs, Honda makes trucks. Similarly, Toyota makes cars, Toyota makes trucks, Toyota makes SUVs. So these could be regarded as families of cars. Toyota families of cars, Honda families of cars. Each have competition, right? Each car, each unit that each company provides or produces has counterparts. So a Toyota sedan has a corresponding Honda sedan. A Toyota SUV has a corresponding Honda SUV, right? So that's the idea. When you have families of objects like that you have to manufacture, then you go for abstract factory design pattern. This is very similar to factory method design pattern in the notion that you have another object, another class creating the objects, but how the object is created or how the other object is related to the parent class is what is different. So that's what we're going to see next. Here, the object creation is delegated to composed class. If you look at factory method pattern, our business logic was in the superclass and object creation was delegated to the children. Just like that, here, the object creation is done by a separate class, and that class is owned by the parent class. So instead of sending it to the subclasses, it is sent to just another class, completely different class, and our factory will have a reference to that other class. Right? Again, the concept is the same. All objects will descend from the same interface. Here we have multiple classes. So what we have here, we have a hierarchy of classes. So generically, you could think of the hierarchy as I have a vehicle which has descendants like car, SUV, truck, and if possible limousine. Right? All these four are families of interfaces. And now Toyota has its own family. Toyota car has Toyota SUV, Toyota sedan, Toyota truck. And similarly, you have Honda, which has its own range. So this is what I mean, the family of classes. And the abstract factory can produce different classes that could produce different families of objects. So I could have a factory that would manufacture Toyota brand of cars. I could have another factory that's going to manufacture Honda brand of cars. So if such a situation arises, then I go for abstract factory design pattern. And remember, the most important difference between factory method and abstract factory is factory method relies upon inheritance, while abstract factory relies upon composition. Right? And factory method, only one class and its descendants. Abstract factory, a hierarchy of class, a family of classes, and their dependents. Right? So those are the two primary differences of factory method versus abstract factory design pattern. Right? And this is why I'm advising you people to pay special attention to the terminology used. Okay? So let's talk about the, let's look at the diagram, the abstract factory design pattern UML diagram. This diagram was directly captured from that book that I was referring to, Object-Oriented Design Principles. So here, they have taken the example of a GUI factory. Here right now I'm using my laptop which has Windows Vista, and you have Windows 7, you have Windows XP. All these various operating systems will have a GUI factory. And every operating system, regardless of Windows or Mac or Linux, all these will have a counterpart for a common component. Like you have a button that looks like, a gray color button. You have a scroll bar, it looks grayish bar and turns blue when you hover in a Windows operating system. This looks like a more aqua blue in Mac OS X. And it looks like a completely gray bar in Linux. So you have the same thing represented differently. You have different variants of a family of components. When I say family of components, I mean the various GUI components, which could include the button, the scroll bar, the radio button, the drop-down, checkbox. All these are various components. And you have Windows-specific components, Mac-specific components. You have Linux-specific components, like Ubuntu-specific components. So you have all these variances. But all these are same. They all descend from the same common root. They're all UI factory components. They are all UI components. When it comes to UI, you could only pick from certain components that are acting as the master set, which include the drop-down, checkbox, text box, radio button. Things get improvised, but the core components, our core set of components, are always the same. And each operating system provides different implementations for the same family of UI. This diagram is a very popular diagram. Do feel free to look at it in that book, or it's also available in Wikipedia. So that's our abstract factory design pattern. In this example, how it's been laid out is you have GUI factory. Okay, a GUI factory must have a button, and it could have radio button, it could have checkbox. So each GUI factory will have multiple GUI components. And the GUI factory is at the root level. It's at the interface level, right? But what you have here is a component. So GUI factory is capable of manufacturing button. And similarly, GUI factory is able to manufacture scroll bar. GUI factory is able to manufacture text box. So those are at the root levels. Now if you take a specific implementation, then you would say Windows factory is able to manufacture Windows button. Windows factory is able to manufacture Windows scroll bar. So that is the correlation that you have to make. You have a factory that manufactures a hierarchy of classes, hierarchy of objects. And that family is determined by the factory. Are you talking about Windows GUI, or are you talking about OS X GUI? Right? So I hope that makes it clear to all of you. If so, let's get into an example of abstract factory design pattern. I'll keep this car factory design pattern because I think I may use it for the next student as well. So hang on, let me open up the next example. So let's compare and contrast, right? So we have the same car assembly over here as well. Oh, not car assembly, it's called car factory over here. Okay, we have the same car factory over here. So in the factory method, we saw that the car factory has the business logic embedded in it, and the object creation has been delegated to the children. But how about the abstract factory? How do we do it if it's an abstract factory pattern? In that case, what you do is you take the object creation alone to a separate class called car factory. So the car factory interface, or any of its implementations, should be responsible for object creation, regardless of the object in question. So they should manufacture car body, they should manufacture tire. Anybody who claims to be a car factory should be able to manufacture all these components. So this is the family of components of a car. A car should have a tire, a body, an engine, and accessories. So these are the family. These form the family, right? So I have a car factory, which is its own class, and I have a car assembly. The car assembly has the business logic embedded into it. You see how this thing differs from the factory method now? In the factory method, I have single car factory. It had the business logic at its level, and the object creation was given to the children. But in the abstract factory, what I am having is two different components. One component specifically manufacturing objects, and the other component specifically employing those objects for business logic. And the latter component is what you're seeing. The car assembly is going to depend upon the car factory right here, the get car factory. So it depends upon the car factory for object creation. Besides that, it has the entire business logic. So instead of embedding the business logic in the parent class and object creation in the children, as was done by the factory method, we are splitting these two responsibilities into two different classes, right? One class is solely responsible for business logic, and the other class is solely responsible for object creation. And that class here is our car factory. And remember, it's an abstract factory. It does not say any implementation is here. It does not have any implementation. It just says, hey, anybody who claims to be a factory, car factory, should be able to manufacture these components. So this is our abstract factory. Let's see very simple implementations. So you have our Maruti Swift factory, and that's able. This is one family, one possible family of our components, right? So one variant, one particular variant of our family, Maruti's factory. We could have Honda's factory. We could have Toyota's factory. So the assembly, the car assembly, is going to simply use the car factory to get the object created. So that's what we're doing here. Hey, car factory, get me the car. And after the car body is built, it's going to work on top of it. This is your business logic in action. So this is the primary difference. Factory method relies upon inheritance. Abstract factory relies upon composition. That's very important that you understand that particular difference. All right. So with that, we've concluded the factory method design pattern and the abstract factory pattern. These are the big ones, the top tips, and we've cleared those, which means we are left with smaller design patterns like the builder design pattern, the prototype, and the singleton. But make no mistake, when I say smaller, I just mean that the concept is simpler. In reality, the builder design pattern is what you will employ when you have a very complex mechanism, very complex object creation problem. In such cases, you'd use builder design pattern. Not factory method, neither abstract factory, right? So what is this builder design pattern? The builder design pattern builds an object gradually in steps. That is iconic of this builder design pattern. I think I said this in the beginning of the session as well. When you use other design patterns, there the object is created immediately. But here, it's only sensible to use the design pattern if you're intending to do it over multiple steps. And it's not just that your intention is that, it's because you have such a restriction. For example, you have to first call a web service, first do an authentication, and then get something from the database, and then approach an external system. And finally, you decide what to create based on the input from multiple systems. So you're using a builder that's directed by an external class. And the builder eventually produces the object. That's very important. This builder design pattern's primary focus is to avoid telescoping constructor problem. What do I mean by telescoping constructor? Just for the fun of it, I put it in there. No, not really. So the telescoping constructor problem simply means if you have an object that has a complex set of attributes, so many attributes, and if you want to build those objects in a single shot, what would you do? You will have to pass all the attributes as part of the constructor, right? So your constructor could easily get ugly with the number of parameters you could send it. So you could have a complex object that has 10 attributes, and if you have to send all those as constructor arguments, imagine the complexity of constructors. And some of these could become optional. I have 10 arguments, some of these could be optional. And that also complicates the problem where you'll have to decide upon the number of constructors. So to address that is the telescoping constructor problem. So avoid such situations, you'd use the builder design pattern. It's the design pattern that you would approach when you have a very complex situation. Like the one that I just quoted, you have to first authenticate the user from a database, then approach and get details from a web service, and then talk to some local systems, and finally build an object. Convoluted process, right? So if you have multiple steps, go for the builder design pattern. And here's how it looks like when you put it in a diagram. You have a director, and that director works with the builder. And the builder is just an interface. Remember, this is from a core design pattern. This is from the creational design pattern category, which is from that book. the Gang of Four book, and that book says favor interfaces always, code to interfaces, not to implementations. So you should never associate two classes directly as much as possible. So here the director is actually dependent on a builder, which is only an interface. And that builder can have multiple concrete builders. So the director directs the builder through multiple steps to eventually get the final object. And each concrete builder is capable of producing a particular product. You could think of this as a factory method pattern running in iterations. Literally, that's how it is. But it's not always iterations, right? You could have multiple methods, different methods called conditionally, iterationally, right? So that's the builder pattern, and you just saw the diagram. It's composed of two components, the builder and the director. The director is the one that calls the various methods on the builder, the one that constructs the object. Okay? So let's take a quick example of a builder design pattern. I'll get all the factories out of the way, and we'll get into our builder design pattern. So here I have a house, a simple and humble house. It has a basement, structure, roof, interior. That's it. Pretty simple and straightforward. And then I have a builder. A builder says, this is an interface. Remember, this is an interface. So it lays down what are the various possible steps that could be involved. Possible steps. And these are not sequential. There is no obligation that you must call these methods in that order. It's just a declaration that each builder should be able to provide these capabilities. Okay? And then there's a concrete builder. Here this guy is able to build the house from the scratch based on various methods. So remember, the builder will not build itself. Someone has to direct it. First do this, then do that. If this is the case, do that. If the number of occupants is so much, then make sure you use so much for the concrete. So many other complex business rules can be embedded right inside this builder, but it's not the responsibility of the builder to build itself. That is when our director comes into picture. And obviously, this being a house, who's going to build the house? It's going to be an engineer. So the engineer is going to direct the builder on how to build the house. Here, I put it pretty straightforward. I've laid it in a straight fashion. I just said, all right, builder, build basement, builder, build structure, build roof, build interior. But it may not always be as simple and straightforward. In that case, you don't even need a builder. Just directly put it in a single method and return it as part of the factory method pattern. The idea is, in each of these steps, your object is progressing to a second level, to the next level. For each and every step you're calling, your object graduates. And finally is when you will have the final object, nowhere in between. Right? So I need to construct the house and finally get the house. Before constructing the house, if you get the house, it's going to be meaningless. Okay? So that's an example for the builder pattern. So with that, let's move on to the next design pattern. I'll answer these questions once I'm done. So whoever has asked questions, please bear with me. So the next design pattern that we have is our prototype design pattern. We are approaching the end of the session, and we have just one more pattern to deal with besides the prototype design pattern. Prototype design pattern is a little bit different from the other patterns. It is what you would use when you want to clone objects. For some reason, you want to favor cloning. The prototype design pattern simply says, do not use object creation. Do not create the objects from scratch. Take a base and clone it over and over whenever you need an instance. There could be various reasons. One such reason is cloning an object is a lot simpler and easier than creating it afresh and setting the parameters. One simple example that I could think of is I am working with my bank, right? I'm doing a lot of transactions in a single day. And if something did not go through, or if there is an error in the transaction, the money should not be credited from my account or debited from my account, right? So it has to be left in a consistent state. In other words, I'm talking about transactions. So imagine that you have an object, my object, right? The object, the bank has a user object, which is my object, user account to be precise, and the user account has been subjected to various transactions. So for them to have an ability, this is only a hypothetical situation. I'm not talking that this is the way to do it. I'm just giving you a hypothetical example, okay? So you have an object, and that object is representative of my bank account, and that bank account has been subjected to various transactions. Suddenly a transaction fails. If for some reason the object gets corrupted, you have no means to go back, right? So what you do is you take the base object, you take the user account object and clone it, work on top of it. And when your transaction succeeds, replace the base object as with this new object. This is one hypothetical example, right? The prototype design pattern is employed whenever you want to discourage creating the object from the scratch. Instead, you should be able to clone the object. It's very important that you clone the object. Another example that I could think of is maybe your object is costly to create from scratch. So you keep an object created and ready in its base form. And whenever you need an instance, instead of creating the object from the scratch, which could involve multiple complex operations, you take a clone of the object that you already have in hand and then work on top of it to arrive at the final specific instance that you need. Right? So that's prototype design pattern. And here's the UML diagram for the prototype design pattern. We have a creator, and it creates concrete prototypes. Remember, as much as the prototype design pattern says that you should discourage, avoid calling the new keyword, you should use clones instead. It does not say how, it does not put those restrictions on the base object. Of course, you need to have a base object to replicate it, right? So yes, when you create the base object, you create it from the scratch using the new keyword. You build the base first, and subsequent invocations will just take replicas of that base. Instead of they themselves creating the base over and over, they just take replicas of the base. So that is the prototype design pattern, and you see the creator, and it works with various instances of a prototype. And when it says create instance, pay special attention. It's not going to create a new object. I'm sorry, not create an object from scratch. It's going to take an existing object, which will be our base, and replicate it. So that is our create instance. All right. So let's get into our Eclipse example or Java demo. Let me close the other relevant examples. So if you get into prototype, here in this example, I've taken so many objects like the album. It's just a dummy object. It has an album name, and then it has clone. Remember what is very characteristic of all these objects that I'm showing up. All these are clonable, java.util.clonable, which means they implement the clone method. If you call the clone method, they give you a replica of themselves, right? So I've shown you album, movie, and show. All these three are three different objects. All these three are clonable, and then I have a prototype factory. So what this prototype factory does is, when it starts up, when this prototype factory starts up, remember that's what's done by the static class, right? It creates classes readily and keeps them in memory. So it has a local hash map, and it creates one instance of each of these classes and puts them in memory. And whenever you need a class, it's just going to, whenever you need an object, it's going to call an instance, call a clone of an existing object, right? So for example, if you need a movie, it's going to call movie clone and create a reference to that clone object. Okay, so this is one implementation of how prototype is working. So this test prototype pattern is our example on how to work with the prototype factory. The prototype factory only exposes get instance. You specify what instance you want, what kind of instance you want. And all that is done to achieve the instance that you're requiring is done inside the prototype factory. And inside the prototype factory, as you could see, all that I am doing is having a replica of an object that I already stored in my memory and giving it back to you. right? So in other words, I'm replicating the object whenever you need one. But the initial object creation per se has that is an exception. You have to use the new keyword to create that. So that's our prototype factory or prototype design pattern. It's not called prototype factory by any chance. That's just a name that I use, people. So don't think the pattern is called prototype factory. The pattern is called prototype pattern. So with that, we get prototype pattern out of our way, and we have the last pattern of the day to discuss. And I reserved the most simplest pattern to be at the last, which is our Singleton design pattern. And most of us know, or even if you did not know, right from the name, you should be able to guess the Singleton design pattern is all about restricting the number of objects to a single object. So you have a class, but you, for some reason, need to restrict the number of instances of that class to exactly one. Then you go for Singleton design pattern. You may ask me immediately, all right, if you're talking about classes and objects, isn't that detrimental if you reduce the number of objects that a class could have? Why would anyone do that? The answers could be multiple. You could think of so many situations where you don't want multiple instances of a class to exist. The simplest example that I could think right off my mind is connection pooling. What is connection pooling? You maintain a predefined number of connections in a pool, and whenever connections are required, instead of creating them on demand, which could be time and resource consuming, you just get the instance from the pool. So imagine that I have 10 connections in my pool. That connection pool itself is an object, right? You don't want that object to be present multiple times. Because if you have 2 instances, then that means you are maintaining 20 connections, which is far more resource intensive than what is how intensive the 10 connections are. It's going to defeat the entire purpose, right? Similarly, what about cache? If your application is maintaining cache, you don't want multiple instances of the cache sitting in your memory. They could quickly go out of sync. There is no reason why you should have multiple instances. It's a maintenance nightmare if you have multiple caches. It already is if you have multiple instances of your application running on various JVMs. Why would you want more pain by having multiple instances of the cache, right, sitting inside your memory? Right? I could quote so many examples like that. So that's the Singleton design pattern. And here's a UML diagram. It's very simple and humble. All it says is, hey, your class should have a private instance of itself, and its constructor should be private. And it should have a public get instance method. The method could be named anything you want. Just one instance of how we should create it, right? So the get instance method should return that Singleton attribute that you have here. By virtue of making the constructor private, you're locking your class in itself. Nobody else outside the class can create it, right? So this is what I have in my example as well. Let me really quickly show that example. And here it is. We have the memory manager. The memory manager has been declared as private. The constructor of the memory manager has been declared as private, and I have a private instance of the memory manager, and then I have a public get instance method. This is a lazy initialization of Singleton pattern, where you only instantiate the class when the need arises. When someone calls get instance for the very first time, that is when you create the object for the first time. The eager instance is creating it right here, and then just repeating them or returning them from here. So for example, I could knock this block off and initialize it here. That's it. So anybody calling get instance will get the class immediately, object immediately. All right. So that explains our Singleton design pattern. And with that, we also conclude our creational design pattern. Just one final word, ladies and gentlemen. If you use design patterns, creational design patterns specifically, the general trend is like that. Like what? Like starting with the factory method pattern, wherein you have one method that's able to create multiple objects, and then you go on for abstract factory, and then from abstract factory, you decide to go to either prototype or the builder pattern. So you start simply, and then you identify where you need more flexibility or which areas are more prone to change, and then you work your way into higher end design patterns. So the most rudimentary is factory method, and the builder could be a really complex implementation. All right. So with that, I'm concluding the session on creational design patterns, and now I can take some questions. And let me look at the questions that have been posted right here in my viewer. Hang on a second, people.
Thank you so much, Vignesh. I have assigned you a couple of questions. Since we are running out of time, maybe you can take up 4 or 5 questions quickly, and the rest of the questions you can take them offline.
Okay, all right. So like Sri Lagna pointed out, I'll take a few questions. I'll try to answer 5 questions. The rest, please send me an email. I'll be very happy to assist you in answering these questions. All right. So Ram's question is, by using design patterns, can we reduce memory? Ram, it depends on how you're using the design patterns. It's like a stick, science and stick example, right? The stick can help an old man to walk. At the same time, the stick can use to break a window, right? So that's the advantage of design pattern. If you use it to the right purpose, yes, you could reduce memory. For example, the example that I just quoted, the Singleton design pattern applied for connection pooling will reduce your memory. But if you are unconsiderate while using design patterns, it could be detrimental. So you have to watch what you are doing with your design patterns. Okay. Core design patterns. How Ram's again asking, how does core design patterns work on a distributed environment? For the most part, most of these design patterns work the same way, but for the Singleton. Singleton is JVM specific, so if you have multiple JVMs, the Singleton is no longer enforced. Or in other words, the Singleton is going to be Singleton per JVM. And similarly, when you talk about factory method or abstract factory, all these are class level changes, right? The factory method depends upon inheritance. So regardless of the number of JVMs, you should have the same behavior. But if you have some resource sharing or resource conflicts that may occur when multiple instances are present, then you may have to be watchful about it. All right. So can this, Raja is asking, hey, can this factory method be a static function? It has to be. It can be, right? If you make it static, remember it is at the class level. So factory method can be made static only if you do not have multiple implementations. So when I say factory method pattern, there are actually 2 simple variants. We have a simple factory and a static factory. What that says is, simply take the ugly object creation piece and put it in a static method. That is what you just asked. Can this factory method be a static function? If you did that, then you are not able to use the factory method pattern any longer. That itself is a specific pattern called static factory, which means you have a specific dedicated class or a method which has been designated as static, and you put all the ugly logic inside it. Right? So you have a lot of stuff you don't like in your home. What do? You throw them into a room, lock down the room, and act as though it does not exist. that room is your static factory, right? I hope that answers your question, Raja. So the design pattern put overhead on performance of application. Under which scenario we should go with design pattern? This is a question that's asked by Dharmendra Shah. Dharmendra Shah, like I said, this is very similar to the first question. Design patterns are not technical specifications. They are best practices. If you use those design patterns in the right sense, they will definitely not cause any detrimental effects in your application, right? What circumstances, each design pattern is meant for its own purpose, right? Each design pattern has a precise problem that it's trying to address, and you use those design patterns when that problem is encountered. So for example, today we saw about various creational design patterns. We use creational design patterns when you need to create complex set of objects, right? So that is the question that we had. That is the problem that we had at hand to employ these creational design patterns. Similarly, if you are talking with databases, if you are talking with multiple algorithms, then you could use the strategy design pattern. If you're talking about patching up 2 different incompatible classes, you could use adapter design pattern. I sincerely urge you to go and look at that book or wait for another session from me in this Techgig environment where I could explain some of these advanced design patterns. The bottom line answer to you is each design pattern solves a specific problem. If you use it correctly in its intended style, you would definitely save time and effort and resource. All right. So that answers Dharmendra's question. So let me take one last question, and this is, in prototype, question 1, before using an object, we first clone it for backup, thinking that the object might get corrupt while performing transactions on it. And if gets corrupted, we use the backup or object cloned object. Question 2, how is the memory? I'm reading the question, hold on people. How is the memory different when we create a cloned object than that of creating a new instance? Okay, to answer the first question, that was just an example that I gave you. Who's the asker here? Sorry, I forgot to see this. Sri Lakshmi, that was just one example that I gave you. Your question 1 says, hey, you are intending to use prototype as a backup. Are you saying this correctly? Yes, I'm saying that correctly, but that's just one instance. There could be so many instances, like the other example I gave, where your actual object is created by consulting various external systems. In that case, you just cannot create the object anytime and every time you need it. You need to share some resources, right, and try to create the object beforehand and reuse them whenever you need them. Instead of approaching those external systems on demand, you have a base version and you just make replicas of that, right? So that's, I think, answering your first question. The second question is, how do you say that cloning is better? Because some of these virtual machines have abilities where instead of creating a new object, if you just say clone, they'll be much faster because they don't have to wait on you to set these individual parameters or properties from the scratch. They know they have everything in the memory and they just replicate it. On the other hand, if you're talking about new object creation, remember I'm not just talking about creating an object, but also instantiating it and initializing it, right? So when you do all those manually, it's going to be a lot slower than cloning an object that's already sitting in memory. It's going to be much faster, and that's the idea of the prototype design pattern. I think the rest of the questions, either the askers or the moderators, Sri Lagna, if you could send them as emails to me, I'd be very happy to assist you. Thank you very much for all your patient participation and cooperation for this 1 hour. Great audience, and I really enjoyed presenting this session. Thank you very much, Techgig, for this opportunity. Thank you very much, people. If you have any questions, you may shoot an email. If your question was not answered, please, don't mistake me. Just send me an email. I'll be able to answer those via email. This is just to conserve some time. Thank you very much, people. I'm done with the session right now.
Thank you so much, Vignesh. That was a great presentation, and thank you also for taking the questions, and apologize for rushing you through the question Q&A session. We have around 20-25 odd questions which you will probably have to take up offline. I'm going to share the questions with you over the mail, and you can share the answers accordingly. For the attendees, the recording of today's session will be available on techgig.com tomorrow. And once again, thank you so much, Vignesh, for your time and support for making this webinar a great success. Thank you all.
Thank you, participants. You have a great day ahead. Bye.